All right, welcome to this video on the properties of exponents. Let's go ahead and talk about how exponents can be combined and the different properties of when we multiply or raise an exponent to another exponent. So before we get started, let's go ahead and talk about what an exponent actually is. So let's look at an exponential expression here, 5 to the third power. And I want to remind you that 5 to the third power means we're going to have 5 multiplied by itself 3 times. So the exponent is the 3. The base is the number that is being repeatedly multiplied. So the 5 would be the base. All right, now, our whole idea here is to simplify expressions. Not necessarily get a numerical answer, though that can be helpful when comparing expressions with exponents. Our goal here is to make it more simplified. So here, I'm going to demonstrate the product of powers rule, which you can see there down below, by expanding our exponents. So if I take 4 to the third power and I expand that, that is 4 times 4 times 4. So those two expressions in blue there are equivalent. And then if I take 4 to the fifth power and I expand it, we would have 4 times itself 5 times. And these expressions are equivalent. Now, if I go through and I count the total number of 4s being multiplied, I would have 8 4s being multiplied. So I can rewrite this as 4 to the 8th power. And we're going to come back here in a second and talk about where that 8 comes from. Here we have two variable expressions. So we have x squared. So we're going to expand x squared. X squared is the same thing as x times x. We're going to expand x to the third power. That's x times x 3 times. So how many x's do we have? We have 5 x's. Now, where does the exponent on the simplified expression come from? Well, it comes from adding the two exponents. So when we have a base here, and as we look at this, we have x squared times x to the third. So we have the same base being multiplied. We add the exponents. This is only true when we have the same base. So this is the actual power of a product of a powers rule. So if we have the base a with exponent m times the base a with exponent m, we can add n plus m. And over here, we have a bunch of examples. 5 to the third times 5 to the 8th is 5 to the 11th. We add those. We can have negative base exponents, or we can have variable bases. All right, let's go ahead and look at 2 examples of more problems we might see without expanding and contracting our exponents. Now, we're also noticing some coefficients. The coefficients here are 3 and 4, and then we have our variable exponents. So what we can do is we can rewrite these where things that can be multiplied by each other are next to each other. Multiplication can be written in any order. So I can write 3 times 4 times n to the 4th times n to the 7th. Now, these two expressions need to be dealt with differently. So 3 times 4, what's 3 times 4? Hey, it's 12. That's it. Now, n to the 4th times n to the 7th, that falls under the product of powers rule where we need to add our exponents. So n to the 4th times n to the 7th is n to the 11th. Very simple, very straightforward. What students often mistake here is they will either add what's in blue or they will multiply these in red. So you got to keep it separate and really think about what you're doing here. All right, let's go on to the next example. This example is a little bit more challenging, a little bit more going on. Same idea. The 7 and the 2, the coefficients, those can be combined. The x squared and the x to the 4th, those can be combined. And then the y's can be combined. Now, Let's go ahead and rewrite this. So we have 7 times 2. Those are our two blues. Then we have x squared times x to the 4th. That was our red. Notice I'm using color here to help us organize our thinking and our thoughts. Then our y's next to each other. So the thing you need to ask yourself is, what is the exponent of y? That second y right here. So what is the exponent of that? What do you think? Well, it's a hidden 1. We need to remember that. It's not 0 on the exponent because it's not there. It's 1 and we don't need to write it. So now let's go ahead and perform our multiplication. 7 times 2, 14. X to the 2nd times x to the 4th would be x to the 6th. What you need to think of is, how many x's do I have? I have 2 x's, and then I have 4 x's, so I have 6 x's. Here, I have 3 and 1 y's, so I have 4 y's. And that is a fully simplified expression. Those are 2 examples using the product of powers rule. The next thing we're going to talk about involves when we have one base with 2 exponents. Kind of what we have here is we have 2 to the 5th to the 3rd. So what we're going to do is we're going to expand this 2 to the 5th to the 3rd. So what we're going to do is we're going to take 2 to the 5th 3 times. So what I've done there is I've expanded that. Now, each of those 2 to the 5th powers is 5 2's. So if I then go back to what we just did, where we add our powers, 5 plus 5 plus 5 is 15. So this equals 2 to the 15th. Now, let's go ahead and do the x, and then we're going to kind of summarize our thinking here. We have x to the 5th to the 2nd power. So what we have is we have 2 x to the 5ths. We've expanded that. Based on the previous rule, x to the 5th times x to the 5th is x to the 10th. So what I want us to look at is these sets of numbers here. Where do these numbers come from? Well, 5 times 3 is 15, and 5 times 2 is 10. This comes from multiplication. So it's a little different than the product of a powers rule. This is the power to a power rule. So we have a power to a 2nd power. We will multiply. So here are a couple of examples. We have n to the 5th to the 3rd would be n to the 5 times 3, which is n to the 15th. Or we have 7 to the 7th to the 4th. We would multiply and get 7 to the 28th. Okay, so when we have a power to a power, we multiply. Now, here in this example below, I've also kind of added a little wrinkle where this is outside of a parentheses. And we know when we have something mathematical outside of a parentheses, we need to bring it in to all the things on the inside of the parentheses. So this 5 out here is going to impact the 2 and the 3. And it's going to impact it with multiplication. So the answer here is 5 to the 3 times 5 times 7 to the 2 times 5. So we would have 5 to the 15th times 7 to the 10th. Pretty simple, pretty straightforward. I wouldn't write this line on my page. I would go straight to here, and we bring it in with multiplication. We're going to do the same here. 7 to the 1st power. Remember, it's not written there, but it's there. And we're going to bring this 3 in by multiplying. So we have 7 to the 3rd, x to the 18th, y to the 15th. Now, you can leave it like that, or you can simplify it a little bit further, because we know that 7 to the 3rd is equal to 343. So we'd have 343 x to the 18th, y to the 15th. So that is the power to a power rule. With the power to a power rule, we are simplifying by multiplying, because we have a power to a 2nd power, and therefore we multiply. All right, here's our fifth and final example. This is going to combine all that we've learned here today. The first thing we need to deal with is this parentheses. So we're going to bring this squared in. Remember, this 2 has an exponent of 1, though it's not there. So we're going to take 1 times 2, 2 times 2, and 3 times 2. So we're going to have 2 squared, x to the 4th, y to the 6th. Do not forget to write all of that down. So we're going to multiply that by x cubed, y to the 4th. Now what I'm going to do is I'm going to reorder my things that are like next to each other. So I'm going to rewrite this as 2 squared, x to the 4th, x to the 3rd, y to the 6th, y to the 4th. Now, this is where we need to go back to the first rule. When we have bases, 2 bases that are the same being multiplied, we add their exponents. So 2 squared is 4, and then we have 7 x's and 10 y's. And that is the answer to our question. All right, let's do a little summary here. Let's go all the way back to the beginning. An exponent tells us to repeatedly multiply the base how many times. So here we have 5 to the 3rd power. All right, let's look at the first rule we talked about, product of powers rule. So this is where we have 2 bases being multiplied of the same bases. We end up adding their exponents. There's a really nice example there. The second rule we learned was the power to a power rule. So here we have a power to a power. And when we have a power to a power, we multiply the exponents. All right, I hope you took good notes. If you don't really understand something I said, go back and watch it again or come ask me a question. Nice job.